2.6 part 2 of the chain rule. So we did the first 4 examples of the lesson last class, and today we're doing 5, 6, 7, and 8. I think we have 4 examples. So 5, 6, 7, 5 examples. Okay, we have 5 examples to do to finish it off. So differentiate S. So S is the function of t. So still chain rule. So we're taking derivative of the group. So we drop the 6. So that's step 1. That's the easy step, derivative of the outside. Okay, now the derivative of the inside, we have to do the quotient rule. Okay, I'll let you get that. I don't know. Sorry, I'm not sure what that is. Derivative of the inside is in a situation where we have to use quotient rule. So the second piece, you just put a bracket here because you have some work to do. It's going to be low, or high d low, sorry, 2t minus 1. Derivative of low is just 1, so we don't have to write anything. You can write the 1 if you want. Minus low d high. Derivative of the high is 2, all over low squared. So there is the quotient piece. Okay, question? Low d high. Oh, I did write backwards, didn't I? I had it right the first time. Thanks, Steph. Sorry, I had it backwards. Should have trusted myself. Because order doesn't matter because it's subtraction. So yeah, sorry. Low d high minus high d low. Sorry about that. Thank you. Just noticed that right when you said that. All right, so now we want to simplify that as much as we can. We keep this over here just as is. This gets to be 2t plus 4 minus 2t plus 1, because a minus a minus. Okay, and all we can do here, the 2 t's cancel, which is kind of nice. I have 4 plus 1 is 5. So I have 6 times 2t minus 1, t plus 2 to the 5th, 5 over. So you're here. And how can this simplify? What can I do here? What else can I do? Well, do you guys see at the bottom, t plus 2 and t plus 2, right? If it's to the 5th, that means everything's to the 5th, right? So if I have 5 of them and 2 of them, if I want to put this together, I have 7 of them. I have t plus 2 to the 7th down there. Okay, because if it's the 5th, that's the 5th, and that's the 5th. So I'm also going to write 2t minus 1 to the 5th. And then I also have 6 times the 5 is 30. This is your fully simplified derivative using the chain rule, quotient rule combo. Can't do anything else there. Nothing else cancels. No, I'm not asking you to FOIL out 5 exponent binomials. Okay. So at this point, you could find the tangent slope by plugging in a value for t. Okay, this is the equation of the tangent slope of that thing. Okay, questions? Okay, so now let's do, look at that. I thought we were going to need 2 slides. We only needed 1. That's great, huh? Wow. So now this one is chain rule with product rule. Chain rule with a product rule. You have a product of 2 chains, essentially. Okay, so you're going to do first derivative of the second So derivative of the second would be you drop the 4, 2 minus 3x to the third, negative 3, plus second times derivative of the first. Drop the 3, pull out the 2x. So look at that. So this right here would be, I'll call this one G, call this one F. Oh no. There we go. Call that one G, call that one F or whatever in terms of first, second. So G, F prime, F, G prime added together. That's just me writing it out in terms of the product rule. The negative 3 is a derivative of the inside. Derivative of the inside here is negative 3. Okay, anything else there? We're not done. We're going to continue here. So this guy simplifies down to 6x this guy is negative 12, the 4, the negative 3. Yeah. And that's it. As far as you can go. You could take these out if you want, but it's not really doing anything for you. They're not even, so you're going to have stuff left over no matter what. So this right here would be your F prime. Hardest part about calculus is understanding that you're going to have ugly answers. Things aren't just nice, smooth, x plus 2, x plus 3 anymore. Trusting the process. Can't count today. Okay, any questions there? Okay, remember, this time it didn't matter which order, right? Because it's addition. So if you say it backwards with the product rule, you're okay. But like Steph, correct me on the last one, that's not okay. Yeah.
So when you take the derivative and you use the product, will that calculate?
Right. So we have a product of, these are a product, and to do the derivative, like the product rule says I have to do first derivative second, right? So do the second, doing that second requires chain rule. Right. So it's more of like identifying, and I think, Ryan, that's the biggest thing when you're going through these, is identifying the rules you need to use. In this case, I see that there's two things that are being multiplied. Now these things are ugly and not nice, okay, but that tells me product rule, and then when I say, okay, first derivative second, I have to do chain rule within that. So, can you do the chain rule first?
Or did you do the chain rule first?
No, I set up product rule first. Because I can't do chain rule. Chain rules is for specific of a group with an exponent. I have two groups with exponents. So since they're being multiplied, I have to do product rule and then chain rule within that.
So you define the product first and then do.
Right. Because the initial, like looking at that, like if we use substitution, right? If we just call this A3 and B4, right? I'd have to use product rule. And so I have to use product rule in this case as well. Does that answer your question, kind of? Or? All right, two more here. So this one here, if h is differentiable function, find the derivatives of the following functions. So it's just using the notation, just understanding what's going on. So if I'm finding the derivative of this using the chain rule, just practice, it would be 3 h to the x squared h prime of x. If you're using the definition, right? You drop the 3, change the 2, took the derivative of the inside, which was the h of x. Say it again.
What is the H?
This means derivative, because this is on the inside. So that's the derivative of the inside. Now what's different about f of x and g of x in these examples? Yeah, so like this one, we simply can take the derivative of this, right? There's no chain rule required. So it's going to be this, but I still have an inside. So this is an example almost like the same thing as we don't have to do chain rule for x cubed. Okay, so this is going to give you like that. So one, the whole function was surrounded. The one it wasn't. You can see it is different. We didn't have to have a derivative of the whole function, just the derivative of the function itself. Yeah. Yeah, so since this one here is in brackets, we just, whatever's in here, we don't care what's in here. We drop the 3, make it a 2, then we take the derivative that's inside. This one's not surrounded, so we can just take the derivative of this. There's nothing blocking us, right? So we don't have to use chain with that. And then, but we do have an inside here that we have to take the derivative of is 3x squared. So this is my inside now. Before h of x is my inside. So that's what changes. Just makes the actual x cubed is the inside opposed to the complete function. Yeah.
So if it was out of brackets and there was an exponent out on g of x, if there was an exponent outside of the brackets, could you times that by h?
Like this?
No, out of brackets.
Okay.
Which is like here.
So this one?
Yeah, like that, the exponent of 3. Could you times that 3, like x cubed in brackets to the exponent of 3?
Yes. So you mean like this?
Yeah.
Okay, yeah. If it's like this, that's what the next example is about. That's a double chain. So we'd have to go 3 out front, minus the 1, make it a 2, do the derivative, so it'd be h prime. So let's do this. Maybe like this. I'm going to use a bracket just to make it cleaner, okay? So she's just asking if there's one out here. So what I drop it. And we're going to do this actually the next example. To there. To the inside, we have to write this now. Right? And then I have to do it again. So then here, I have h prime prime, which we haven't done second derivatives yet. And then it'd be 3x squared. You have to double chain it. Okay, that's coming later. I might as well answer it if you don't have to write that down yet, you don't have to. But double chain rule. Okay, we will do that though. All right, so this one, find y prime, we have a double radical. So it's easiest to write this as x plus x squared plus 1 to the 1/2 to the 1/2. Best to write it like that. And now we go ahead and start using our chain rule. You have a chain within a chain here, because the first one's fine, but this piece, so you have to use chain rule again. So that's what I mean. Drop the 1/2. Okay, we're there. Now I have to derive the inside. Derive the inside, 1, because derivative of x is 1. To do this one, I have to use chain rule. Whoops, sorry. This right here. It's a negative 1/2 now. Okay, so respectively, what we have right now is we have this. Yep. Yep, so that's the derivative of the inside. I have to chain rule this guy right here I took the derivative of. So I drop the 1/2, subtract the 1, derivative of the inside is 2x. Okay, I'm probably going to need a second page for this one. But so what we have to do now is we want to get everything, like we don't like the 1 here. So we want to go ahead and get this 1 to be similar to this guy. So we're just going to have a common denominator. So it would look like this next, and then I'll probably have to go to the next page. Okay, so the step that I did here, the only thing I changed was I needed the bottom to be this for the 1. So remember, anything over itself is 1. So I wrote the same exact thing over itself with a common denominator. So I can now put these tops together. Once these tops are together, then we can actually multiply these and combine it to one fraction. Yep.
Is there 1/2 of it says the bottom of like the 1 over, like on the left one, like it's right, there's a double 1.5 like on the one side of the bottom, you know what I mean?
Oh, yeah. That's why I have this bracket here. Thanks. I was like, why did I have that bracket there? Okay. So we'll put these together here. One thing you'll notice, which we can go ahead and do since it just kind of works out, notice how these both have a 2. I can cancel it, and these both have a 2. So when they cancel, I still get the same common denominator. So that's kind of helpful. Okay, you can add them together, and then everything will have a 2 still, and you can do it then. Doesn't matter when you do it, but all of them have 2's there. Okay. Yeah. It's really hard for me to write down here, sorry. 1 over 2, yep. Okay, let me know when you're good there. I'll pause the video for a second, and then I gotta switch to the next page here. So the next piece we're going to have, let me go back real quick. So I want to write x plus times, whoops, x squared plus 1 to the 1/2. Putting those together because they're x squared plus x because they have the same common denominator. Okay. Remember, we can't cancel that there because that goes backwards. We put those together. So if you're saying, oh, we can just cancel this, well, if you do that, then you're back to the 1 being separate, which we don't want to do. Okay, so we only leave it like this. And we multiply that, so that gets that to the top. So x squared plus 1 to the 1/2 plus x And how do I write this on the bottom here? Yeah, we just put it on the bottom. Okay, and then from this point you can write it with radicals if you'd like. Okay, we can just stop here for now though. I'll just leave it like this. This is still the derivative. We still did all the steps. Okay, simplification will come later. But that'll work. Okay, I'll pause it if you have questions.